I'm in. This is the VTech Little Talking Scholar, released in 1989. It's an educational toy, presenting basic matching games with canned spoken instructions.
Hello, let's start gameplay. Insert a card.
Styled like an early laptop, it went with the totally adorable choice of using punch cards as the mechanism for selecting different quizzes.
Find the answer for question 1.
These also serve as a display service for instructions on how to use that quiz, since, of course, there isn't a real display. Now, these are a bit after my time, so this isn't a nostalgia trip for me. I don't even remember seeing one before a few months ago, when I saw a post from Binji on Mastodon, joking that the one they found in a thrift store was their new cyberdeck. And something about the design just grabbed me. This needed to be more than a joke. Yes, it should be turned into a cyberdeck. If you haven't been exposed, cyberdecks are a niche trend of people making quirky, aesthetically driven little laptop palm-top things inspired by classic cyberpunk, whose practical utility isn't really the point. They look like a lot of fun, and I wanted to make one, but as always I was just waiting until inspiration struck. Well, wham! This was it. The goal was, basically, make it real. Install a display in the recess in the lid and jam a processor inside to make it actually work. Step 1. Get one off eBay that seemed like it was in good shape and figure out if this is at all possible. It's a robust little design, with some nice features like this storage compartment for the punch cards in the base. And there's also this mysterious bit in there, which is a cover for a little hole in the case. Not an aftermarket modification. This was built into the injection molding dies for the case. Interestingly, what seems to be the processor on the logic board lines up fairly well with it. Weird. Anyway, there was plenty of room inside the case once the old logic board was pulled, and the lid recess seemed just deep enough. It would be tight getting a display in there, while still leaving enough room for the punch card to slide behind, but plausible. If worst came to worst, I could always 3D print a replacement back half for the lid to give myself more room, but I really didn't want to do that. That sounded annoyingly difficult to get right, and at that point, I might as well just make a whole new device from scratch. In addition to adding the display, all the buttons would need to be hooked up, and, just as importantly, the punch card reader would still need to work. I wanted to turn this into an exploration of a more deliberate, more intentional form of mobile computing. Like most everyone else, I don't entirely love my relationship with my phone. I'm too dependent on it, and not even for important stuff. Too many hours lost doing nothing, and it isn't even particularly fun. Just emptiness. The Little Talking Scholar seemed like a great platform for challenging this. It has enough buttons that I should be able to do most things, but not easily. The punch cards only have 6 bits each, so they were never going to be useful for data entry. That's only 3/4 of a single byte. But they did suggest a way to break out of the endless, mindless cycling from app to app to app on my phone. What if, to show a different mode, you have to change the punch card? Want to check the weather? Slot in the weather card. Want to read an ebook? There's a Project Gutenberg card for that. Briefly wonder if anyone has posted anything in the last 5 minutes while reading that ebook? Well, you're going to have to deliberately, consciously change modes in order to find out. Step 2. Sink a bit more money into this and buy some hardware. I went with the Hyperpixel 4.0 Square because it was almost the perfect size, looked to be thin enough, and is made to interface with a Raspberry Pi, which I was already planning to use. And there aren't many options for square displays anyway. I went with the touch version because it has a furled bezel, but I didn't think I'd be using that functionality. After getting the display working over a ribbon cable, I was convinced the project was feasible. The display definitely wasn't going to fit with this massive connector on the back. That alone took up at least 5 very scarce millimeters. So I set about removing it, which was a delicate task on a delicate item. Desoldering the pads one by one wasn't working very well, but luckily the plastic shell could be levered off, leaving individual posts to be removed one by one. It still needed to be wired to the Pi, of course, but I planned on making the lowest possible profile connection, directly soldering wires to the bare pads. With the bulky connector removed, I could move on with figuring out how to mount it inside the toy's lid. My goal was to print a bezel which would get permanently glued down, and then mount the display in that using the mounting holes on its back. The tricky part is that I always wanted to be able to remove the display, since damaging it during development was hardly unlikely. I didn't want to just entomb it inside the bezel with no way to get it out again. It needed to be able to slide in after the bezel had been glued down, and then screwed in place that way. My 3D printer was still down, however. The combination of my Photon M3 being relatively old and the ongoing supply chain fuckery made getting even replacement parts a real pain. So this was outsourced, but I didn't entirely mind that, as I quite like the feeling of SLS prints. The first one fit nicely, but I realized having this crossbar going all the way across the back was a mistake, as it would get in the way of the wires running to the display. The lower left side of the display also felt a bit wobbly, being so far away from such a thin mounting point. In case I ever wanted to use the touch functionality, that would be really annoying. The second version worked much better, with a gap between the mounting supports and a little backing ledge for the display to rest against on the side. Before taking the step of permanently gluing the bezel in place, though, I needed to make sure I could actually slide the display into it afterwards. That meant milling away some of the internal reinforcing ribs from the plastic case. I wasn't too worried about the loss of structure, though, as this thing is pretty overbuilt. I'll be treating it with a bit more care than its original intended audience anyway, I hope. Sliding the display in felt plausible, at least as far as I could tell while holding the bezel in place. So I went ahead and epoxied it in place permanently. With just a bit more milling, it worked. It was a tight squeeze getting the display in, but it didn't make any heart-stopping cracking sounds, and it didn't even scratch the screen when I did it the final time with the protective film removed. So that was one major question mark resolved, but another came quick on its heels. Would my harebrained wiring scheme even work? The only way to learn is by playing, so I dived in. It was a finicky job, not helped by the fact, as I realized later, I had never turned the heat on my iron back down from the desoldering job earlier. That's why the insulation kept melting away. A favorable interpretation of this is that it shows how focused I was, that I didn't stop to ponder this more deeply at the time. But I eventually got all 40 display lines connected, plus the 4 which provide pass-through I2C connection from the display. The first test was almost a perfect success, with just one color channel being obviously wrong. I quickly found the broken connection, resoldered it, and full success. I did have to resolder a couple others the next day, which broke as I was making the wire routing a bit more permanent. That stopped happening though as soon as everything was locked down, and the back half of the lid could even be attached. But punch cards couldn't reliably be inserted as their edges kept snagging on the wires. So I sacrificed another 1/3 of a millimeter to add a protective cover, using one of the original toy punch cards as both a nod to its origins and an act of laziness. With this added, the cards no longer snagged while being inserted, but now there was enough friction that it was kind of a struggle to get them in. Way too much to be satisfying, and applying that much force to such a delicate system made me nervous anyway. Happily, I remembered a bag of little M3 washers had been sitting on my electronics bench ever since I was playing with Eurorack modules deep in the early pandemic. One of these, for each of the screws holding the lid together, provided one full extra millimeter of clearance, while not quite opening up any unsightly gaps around the perimeter. And the card slid in perfectly, and the display still displayed. With this working, I became a lot more confident this project would be successful. That covered the output side of the hardware, but what about the input side? There were the 8 main color buttons, plus repeat, on, and off, as well as the 6 bits of punch card state. That would need 17 lines of I/O on a Raspberry Pi that had exactly 0 left over after the display was connected. Luckily, the makers of the Hyperpixel display realized this might be an issue, and there's an I2C pass-through built into the display. So now I just needed to hook up an I2C port expander, and as luck would have it, I just finished a project making extensive use of the MCP 23017, so I had extras laying around and was very comfortable using them. Okay, it was slightly annoying that each one provides 16 lines of I/O when I needed 17, but it's not like they're expensive. What was really annoying was later realizing that some of those could have been hardwired to ground, saving me at least 2 I/O lines and an entire MCP 23017. Blast. Space inside the body of the cyberdeck wasn't going to be nearly as tight as in the lid, but there still wasn't a lot to spare. So I made a custom PCB for the port expanders, just to keep everything as compact as possible. This, too, took much longer than necessary, as some angry toddler had decided to mess with the global supply chain. But eventually it showed up and was quickly assembled. It always is nice when you can do an entire electronics project just with components you already have on hand. I ended up removing the speaker to make some extra room for cables. Not that I had any plans to use it anyway. I know this is a little talking scholar and all, but I almost never want my devices talking at me. I had designed the port expander board to take the existing ribbon cable from the button panel, but I realized that meant I could solder them directly to each other, with bits of wire bridging each matching hole. A bit unconventional maybe, but this removed that section of ribbon cable entirely, and generally kept things a bit tidier. There ended up being plenty of room for the Pi Zero to fit using its standard ribbon cable connector, which was a great relief. I really didn't want to have to perform a repeat of that stunt with the display. In the end, I didn't actually firmly mount it at all, as it was held quite securely just by the mess of cables around it. At first, power was just a micro USB cable coming in through a hole in the battery compartment. Having a bit more time than I expected for this project, I later found the smallest external battery possible and pulled out the cell. This was too big to fit in the 4AA battery compartment, but as far as I can tell, there was about a 1/4 inch clearance on the other side before you would hit the lid axle, and it looked like I only needed to move the battery down by about a 1/4 inch to make it fit. So I put it back in the mill and started cutting a slot in the bottom of the battery compartment. Securely clamping the case without damaging it was a problem, until I realized it already had 7 perfectly good mounting holes in it. I just needed to find some wood screws that fit and carefully screw it down to some scrap plywood, which worked great. At first widening the slot by 2 mm at a time, then 1, then just a half, I crept up on the exact right width, where the battery fit inside the compartment, but was still held firm just by the cover snapping in place. Perfect. I had been avoiding modifications that would be visible from the outside, other than the display, but for this to be a real completed device, it was gonna need a charging port. Luckily, they make nice little cable extenders made to be mounted in dashboards, so I just needed to cut a square hole for that. Not the most rigid of setups held vertically like this, but more than good enough for milling plastic. Some tests showed that it lasted over 5 hours on battery, running a mode that reloaded Mastodon every 10 minutes. Not a heavy load, but not just sitting idle either. And it could recharge in about 4 hours, even while running the Pi at the same time. To prevent it from always running the battery all the way down, a power switch joined the charger port, drilled with an end mill. I was worried a normal twist drill at that diameter might bite too aggressively into the thin plastic shell, either cracking it or doing some other damage pulling it up out of the vise. Finally, everything could be soldered together on the inside, including the battery charge controller, except I got the battery lines crossed and let out the magic smoke. 3 lucky things about this. I caught it on camera, the battery had cost like $7, and it came in packs of 2. Having convinced the other one to donate its charge controller, I could shove it all inside the case and somehow successfully seal it back up, hopefully for the last time. And the hardware sides of things was done. The Little Talking Scholar was released in 1989. Also in 1989, Sun Microsystems released its classic Unix workstation, the SPARCstation 1. To properly appreciate just how radical my modifications here have been, let's compare that with my new cyberdeck. Processor: single core 20 MHz, quad core 1000 MHz. Memory: 64 MB, 512 MB. Display resolution: 1152 by 990, 720 by 720. Display color depth: 8-bit, 18-bit. Storage: 424 MB, 32,000 MB. Cost: $15,400 in 1989, or about $40,000 today. $200. Okay, let's do a tangent. The way we commonly quote monetary values is kind of ridiculous. $1 lacking any temporal reference, could mean anything from $1 today down to about 3 cents. Which is frustrating, because we know that not only does inflation exist, but that it isn't even constant. We also know that people are very, very bad at reasoning about exponential growth. Even just static exponential growth, much less that where the rate of change is itself changing. Yet we continue to quote monetary values as if they have some fixed meaning, at most adding a little disclaimer like I did above. It's downright disingenuous at times, particularly when budgets are involved. Want to make a piece of public infrastructure sound particularly expensive? Talk about it in predicted dollar values for the end of the project, maybe decades in the future. My first proposal is just that it should be the standard to always quote monetary values with the year to which they apply included as a subscript. This would solve most of the problem just by making it clear that someone should run an inflation calculator if they want to know what the value means in modern terms. Any values without this would stand out as incomplete, making deceptive shenanigans a bit more obvious. But if we're going to do this, let's really get into the weeds. I think the professional standard should be that values are quoted not in terms of their native year, but projected back to the previous even decade. So 15,400, 1989, would change to 9,900, 1980 instead. This way, you wouldn't even need to pull up an inflation calculator most of the time. Historical references are pretty heavily weighted towards the recent past, so we'd mostly just be seeing values quoted in the same handful of decades over and over again. We'd all develop decent instincts for the relative value of currency at those time points. It could also have some interesting effects on inflation itself, which is as much a psychological phenomenon as a response to any specific stimulus. It'd be a bit like continuously running Brazil's experiment with the real, and if you haven't read up on that, I suggest you do. It's a fascinating story, but a little bit out of scope for this video. Anyway. That left the software side, which I had actually started a few weeks earlier, wanting to make sure I had something ready in time for OpenSauce this year. Because, only having the 1,000-key, 5-foot-wide 1000 keyboard to show off as a new project felt a bit sparse. The Pi needed to interface with the I2C port expanders, which meant figuring out which I/O lines were connected to which parts of the physical hardware and how to read them. The punch card bits were pretty simple, they just needed a single line set to low. The MCP23017s have built-in pull-up resistors, which is very convenient, though the Python library I was using hadn't exposed that functionality yet. Which, remind me, I still need to submit a pull request for that. The panel buttons were a bit harder though. The PCB layout is very 1980s. It took some puzzling out, but I needed to use these lines as input to read the state of the buttons. The others needed to be pulled low, but in the case of these three, they are connected to buttons being read from multiple input lines. That means they had to be pulled low one at a time, the state of the relevant buttons checked, and then put back to high to prevent ambiguous results when the next one was pulled low. It makes sense that this one was simpler, as that's the power on button, so it can directly trigger the wake-up process, while the others can be part of a more complicated matrix scan. What this means is that while these three did, indeed, need to be set through the port expander, I could have hardwired this one to ground, saving another I/O line. Oh well. I also realized why the layout looks so weird. It's single-sided. Tracks only on one side of the board, and no vias, the little tunnels that connect traces from one layer of the board to another. That means traces can't jump over each other, forcing convoluted layouts like this. If you look at the logic board, it's the same thing, but they couldn't avoid adding jumper wires to do the bridging. You can still make single-sided boards, of course, but I can't imagine bothering unless you were etching or milling them yourself at home. I don't think it would even save you any money with any of the fabs I've used. The past is a foreign country. I won't go into the application development process too closely, as I don't think it would be that interesting, and this was hardly my best code anyway. Basically, a bunch of modes are instantiated, with a main loop that watches the state of the punch card lines. If there is a mode associated with the 6-bit value it gets from the punch card, the update method on that mode is called. If there isn't a card inserted, or it doesn't recognize the value, which can happen as you insert or remove a card and not all of the switches are fully thrown, it defaults to the idle mode. This just shows the same insert punch card pictogram as is embossed on the back of the lid, which I thought was pretty snazzy. It's completely hidden by the display now, so I was glad to bring it back in spirit. This started as clean black and white, but as I got into the retro-futurism vibes a bit more, it later became this more evocative version instead. I had been feeling like doing more software projects recently, and this ended up being a super fun outlet for that. I had originally meant to do just a handful of modes as an example, and ended up with 9. It was so fun I just couldn't stop. The constraints of a small square screen and only 11 buttons to work with proved really interesting, though not all the modes were too bothered by that. I started with a weather mode, querying the OpenMedio.com API for data. I found this open source weather icons font, and found myself really liking the faux monochrome CRT look. Like all the modes, this was done using Pygame as the layout engine. Later, thinking about showing it off at OpenSauce in the Bay Area, I wanted to make the location user-settable, instead of just being hard-coded for Seattle. The API just wants latitude and longitude, so I added a way to switch to a map with a targeting reticule. The trick was to find a base map that was in an equirectangular projection, where you just treat longitude and latitude like Cartesian coordinates. Not a projection I would usually use, but while being completely useless for any actual cartographic purposes, it is by far the easiest for converting from XY screen coordinates to geodetic lat-long coordinates. I also added a similar mode for showing headline news, using the newsapi.com. I'm not entirely thrilled with the journalistic quality of the content, but it's good enough. This required a bit more interface, with the ability to scroll the page up and down, including scrolling faster if you keep the buttons held down. A clock app was obviously needed, but it felt a bit bare. It wasn't too much more work to add a stopwatch function with lap time. I didn't want to add an alarm feature though, as an alarm that only worked if you had the right punch card loaded would be a bit silly even for me, and one that you couldn't silence until you inserted the right punch card would be sinful. Next, Free Cell Solitaire. This might not sound like a critical mode, but it is to me, having been addicted to it on mobile devices going back to a Windows phone ages ago. I was particularly looking forward to the chance to finally implement my personal rules on it. See, the goal is supposed to be to get all the cards up into the foundations in the upper right. But I never really liked how the game got easier and easier as you went along, until almost all you're doing is sliding cards up into the foundations. If you've ever played with automatic moves turned on, you'll know what I mean. Every move can unleash a landslide of cards, which get bigger and bigger until the game is suddenly over without any warning. Not very satisfying, to my mind at least. Instead, I tried to build up 4 complete columns down in the tableau. Any use of the foundations I see as a failure, and any game with more than 1 or 2 aces up there isn't really worth continuing with. This means games are no longer all theoretically solvable, but that's okay. I just really like how the difficulty remains much more constant this way, with the possibility of stalling out remaining very real, sometimes until just a few moves before the end. I found a charming little text-based Python implementation and started hacking from there. The limited interface was a real constraint here, which made for an interesting problem. The solution I ended up with was to divide the field into the upper and lower halves. First you choose which you want to interact with by hitting one of the 2 leftmost buttons, red or purple. Then you choose which column within that section you want, using all 8 buttons. This sets the source for the next move, and you do the same thing again to choose the destination. Then it was just a bit of work to reward each completed column with a little animation, like I've always wanted, and it was done. I really love how it turned out. I'm kind of an old-fashioned guy at times, and I kind of love enigmatic, old-fashioned interfaces. I realize some people see bad interfaces as repellent, but to me they can be an exciting puzzle to be mastered. The use of color here does break the monochrome CRT vibes everywhere else, but I don't really care. I also implemented an ebook reader using some favorite Gutenberg titles. This meant a file explorer, but the interface on that was pretty simple. I also later added the ability to change font size up and down, rewrapping the text automatically, which was then extended to all of the text-heavy modes. Since mobile computing isn't complete without social media, I also added a very simple Mastodon client that just shows public posts from your timeline. You can't post, and you can't even see comments yet. Downloading, caching, and displaying images was a new trick, and getting them to look appropriately cyberpunky was fun. I ended up using an ImageMagick dithering filter. I don't know, maybe it's too much? But it was fun. It was at this point I also added a network activity screen, as the limitations of the Pi0W were becoming obvious. At least this way you'd know you were waiting for network access to finish. At the suggestion of a very wise friend, I added a Wikipedia mode, which definitely felt in line with the early internet vibes of the thing. It also reused the Mastodon download infrastructure nicely. At the moment it just loads a random page, but it does show the default image if there is one, and even wraps the text halfway decently. You can also scroll through all the page links and follow those. I should probably add a way to search for specific things, but it's not like getting lost down random Wikipedia holes isn't fun on its own. And search would require text entry, like the Notes app does. This pushed the interface to its very limit. How do you enter text using only 11 buttons? You could do some kind of chording input, but the button layout isn't super conducive to that. And I wasn't wild about the idea of teaching myself an otherwise useless chording system. I did that once with the Twiddler back in the 90s when I was trying to build a wearable, and repeating the experience did not appeal. 8 buttons did make me think of directly inputting ASCII bytes, of course. Technically, that would just be another form of chording, but at least I might gain something from better memorizing the ASCII table. Hint, you actually only need to know 3 values in order to be able to deduce all of the letters and numbers in ASCII. The 0 character is 48, capital A is 65, and lowercase letters are all 32 more than their uppercase version. Seriously, that's it. Let's say you want a 7 character. Start at 0, which is 48, and add 7, giving you 55, which is, in fact, the 7 character. Lowercase m? M is the 13th letter, so starting with A at 65 plus 12 gets us an uppercase M at 77, plus 32 gives us lowercase m at 109. This works because all the numbers follow each other sequentially, as do the letters, and capital letters come before lowercase. This was intentional so that directly sorting text by its ASCII values would give you semantically meaningful results. And the fact that upper and lowercase always differ by 32 means that the only difference between them is the state of the 6th bit in the byte. If you ever need to quickly test for uppercaseness on a bit level, there you go. Plus, if you remember that almost all text only uses the lower half of the table, that means the 8th bit will always be 0, which makes ASCII text printed in binary kind of obvious, at least if you're assuming English. This might not seem useful, but look around and you'll see it. People love to hide ASCII Easter eggs whenever a block of binary shows up as set dressing in a movie or a video game. The consistent leading 0 on each byte is a dead giveaway, and you can always deduce the values if you just remember the rules above. But as fun as that can be, I wasn't thrilled at the idea of doing it constantly while entering text. There is a well-established system for entering text using an even more restrictive interface though, and I already kind of knew it. Morse code. It's been a long time since I got my Tech Plus ham license though. I'd like to say I kept in practice, but the last time I put any real effort into it was during a month-long canoe trip in the Canadian Arctic. Not because I was actually using it though, just because a key was printed on the back of my signaling mirror and I was very, very bored. Letter codes in Morse are all 4 characters long, either dots or dashes. So first I tried using the full keypad with the upper row dots and the lower dashes, each column representing a symbol in the output. So to enter V, did-da-da, I'd push red, yellow, orange, black. This worked, but it felt pretty clunky. It also left me with no good way to enter numbers or any of the other longer Morse codes. Codes Morse? So I switched to treating the 2 leftmost buttons like a paddle key. On a classic straight Morse key, you form dots and dashes by how long you hold a switch closed. A paddle key, however, will generate a streams of dots automatically as long as you hold down the left paddle and dashes for the right. They're a bit more complicated than a classic key, but they allow for much faster input. Implemented on the cyberdeck, they also felt a lot more comfortable to use. It also freed up 6 buttons, which I assigned to utility characters like punctuation and enter. The full Morse table is too big to print on the edge of a punch card, so I added an optional key at the bottom of the screen. For a bit of extra flair, I made it so the character being entered updates as you type in the code for it. So if you keep typing in dots, it'll change from a cursor to an E, to an I, to an S, to an H, to a 5. This probably isn't useful and might actually be distracting, but it's just so cool I had to leave it in. At the last minute, I added a 9th utility mode when I realized I had no way to exit out of the LTS program once it was running if I wasn't SSH'd in from a nearby desktop. All it does is offer a kill action on the off button, but maybe I'll add some way to select or add new Wi-Fi networks or change the system time or something. It was about this time that the hardware side was done, so it was time to deal with making the punch cards. At first I was using some of the ones that came with the device for development purposes, but I discovered something odd. Out of this entire stack, there are only 6 unique hole patterns, and that actually means only 3 distinct cards, since half of those are the inverted versions from the backside of the same card. Obviously, with only 6 possible holes, the number of distinct patterns was going to be something under 64, but for the actual population to be as low as 6 was genuinely shocking, and inconvenient because I had already written 9 different modes for it. So I had to cut some extra holes just to continue. But eventually, I had to make my own. I have a great fondness for punch cards. They're from well before my time, but I just love how tactile they are, nominal like a call-it block. And their connection to the earliest forms of computing and digital data entry is also pretty neat. I even made a cocktail robot which used them for the ingredient selection once. If a connection was made through a hole, that changed the resistance on a 555 timer circuit, altering the width of the pulses it was sending, turning a servo to open a valve. One of the first times I made a custom PCB. Like the original toy, the numeric value punched in each card was completely arbitrary, just needing to be different for each card as long as I updated the software to know what was what. Unlike the original toy, the vast majority of the card surface would be hidden from view by the display, so there wasn't too much graphic design involved. But I still wanted the remaining bit of card that sticks out the side of the lid to provide usage instructions, at least for the mode simple enough to allow that. This was my first excuse to use the laminator I found misfiled in the kitchen department at a local Goodwill when I was looking for a waffle iron for the Labyrinth waffle project. And I'm happy to say it worked, so that was $10 well spent. The holes needed to be a fairly precise rectangular shape, placed fairly precisely. None of the standard craft paper punches I could find came close to the right shape, and none of them are really designed for precision targeting anyway. But then I found a leather punch set that happened to contain a punch just 1mm longer than needed. It's a bit awkward to use and slow, but the results are much cleaner than when I tried using an X-Acto blade. To make the cards a bit nicer to hold and a bit less likely to snag when being inserted, I borrowed back this lovely old corner rounder punch I got from my wife a few years ago. It worked great and was great fun to use, but the 1/4" radius was a bit large. I ended up buying a handheld one with a smaller 3mm radius for the final cards. With the full system installed and integrated, I stopped being able to ignore the problem with how very, very slow it was. So at the last minute I upgraded it to a Pi Zero 2W and got a faster SD card too. And while still not exactly fast, it is much, much more usable this way. Scrolling in the Mastodon and Wikipedia mode still hangs, but hey, it's a kid's toy from 1989, I'm not sure what you expected. And there it is, my little talking scholar deck, with a full set of cards ready to be used. As always with these experiments, I set about using it for a week to see what living in this alternate history would have been like. It's actually not entirely impractical, and it definitely fulfills the goals of reducing mindless device usage. You really have to want to use this thing. Will I keep using it regularly? I'm not actually sure, but I have become unreasonably fond of the silly little thing. I just feel calmer using it. It'll need more software improvements, though. Comments on Mastodon sure would be nice. And maybe some more games. And if you want to play with it as well, come find me at OpenSauce, July 19th through 20th at the San Mateo County Event Center. This will be there, as well as the 1000 keyboard, the D10 spinner, and whatever else I end up loading into the van. Booth locations haven't been announced yet, but I'll post here as soon as I know. Hopefully the stained glass globe video will be coming out not too long after that, as I really do need to finish that project. But there will likely be a gap of a few months after that, as I was recently contacted by someone who wants their own kinetic goose sculpture and was willing to pay for it. I'm looking forward to putting to use some of the lessons I learned building the first one, and I think I'm going to use it as an excuse to completely rebuild the gantry crane in the outer shop. I'm not sure how video-worthy any of that will be, but we'll see. Cheers!